You saved $50 on a part. In a crash, that discount could turn into a $50,000 hospital bill, or worse. This isn't scare talk. Crash tests show that non-OEM repairs can change restraint tuning, throwing off airbag timing and seatbelt performance. Today, we're counting down 13 parts that look like easy wins at the register, but quietly sabotage safety and reliability. From subtle sensor swaps to budget components that can wreck engines, each one carries a hidden safety tax you won't see until it's too late. Stay to the end to spot the sleeper item most drivers overlook. Before we move on, please take a moment to subscribe to the channel and like the video. Number 1. Cheap oil filters. That $6 filter can starve your engine at 4,000 RPM. Do you know what its bypass valve is set to? If it pops open too early, you're pumping unfiltered oil when the bearings need it most. Cheap filters cut corners with thin media, weak anti-drainback valves, and out-of-spec bypass springs. Nitrile valves harden with heat, causing dry start rattle after overnight sits. Teardowns show collapsed media and glue joints, letting seams split. Oil analysis often reveals silicon and iron spikes after media tears, and OEM bulletins warn that non-spec filters skew VVT behavior and oil pressure sensors. Number 2. Low-quality air filters. More airflow sounds good, until your cylinders sandblast themselves. Low-quality air filters chase flow by loosening the weave and thinning the media, and that fine dust doesn't just vanish. It bypasses, coats the MAF, and starts grinding rings and compressor blades. Cheap gaskets leak around the edges, too. On the dyno, a fouled MAF skews readings lean, causing hesitation and knock risk. ISO 5011 testing shows big gaps in filtration efficiency between OEM grade and bargain filters. Off-road, oil reports spike in silicon when dust gets past poor media. We've also seen MAF contamination force limp mode. Number 3. Off-brand spark plugs. One wrong heat range can melt an engine under load. Off-brand spark plugs gamble with reach, heat range, and resistor value. And that's how pre-ignition starts while you're climbing a grade or towing. Get the reach wrong and you change combustion temperature. Too long and the tip becomes a hot spot. Too short and the flame kernel struggles, so timing chases knock. Counterfeit iridium tips erode early, widening gaps and spiking misfires. Those misfires dump raw fuel into the exhaust and cook catalytic converters past $1,200. Dyno logs light up with knock after incompatible plugs, and coils overheat from improper resistance. Use OEM-specified plugs to keep timing stable. Stopping is non-negotiable. That bargain brake pad can change how your car crashes. Number 4. Knockoff brake pads. Would you trade 60 feet of stopping distance to save $30? That gap turns a near miss into an impact. Knockoff brake pads fade fast because their friction coefficient swings as temperature rises. On independent dynos, cheap compounds lose bite within a few hard stops, then shed unevenly. We've seen pad material delaminate from backing plates during heat cycles, a failure type tied to recalls for glue separation. SAE J2522 tests highlight unstable mu curves and poor recovery after high-speed stops. Wet braking gets worse. Water film plus low-quality resin means long pedal, late ABS, and confused ESC timing. Number 5. Aftermarket sensors, O2/MAF. The sensor is a $60 part until it turns your engine into its own worst enemy. Non-OEM O2 and MAF units often read slightly off or react slower, and that tiny error snowballs into rich, lean swings, hot catalytic converters, and surging. Watch closed-loop trims drift when an O2 switches late. The ECU chases the target and overshoots. Scope captures show lazy crosscounts and flat spots. A miscalibrated MAF reports the wrong grams per second, so load and timing shift, inviting knock. OEMs warn against non-approved sensors for this reason. Emissions tests also fail from elevated HCCO and NOx. Number 6, cheap timing belts or chains. A $40 belt can bend $4,000 worth of valves in 1 second. Low-grade belts crack early and shed teeth when heat cycles build, while bargain chain kits stretch and rattle until timing slips. Interference engines don't forgive. When timing drifts, pistons meet open valves. Case studies show tooth shear followed by P0016 crank/cam correlation codes, and chains lengthening enough to jump a tooth. Counterfeit kits mimic OEM boxes, but use softer rubber and lighter guides. OE intervals assume proper materials and tensioners with hardened springs. Cheap springs lose preload, letting slack form. Owners report warranty denials after non-OEM failures. Number 7, low-grade fuel pumps. Your car runs fine until a hot day and a quarter tank turn your pump into a ticking time bomb. Low-grade pumps cavitate early, drop pressure, and overheat without thermal cutoff, so the engine goes lean under load. Watch a fuel pressure plot against throttle. Pressure sags, wideband O2 shows lean spikes, and detonation follows. Many cheap modules use plastic impellers that swell with ethanol blends, choking flow. In direct injection cars, a weak low-pressure pump starves the HPFP, causing surging and power loss. Returnless systems feel every fluctuation, and some aftermarket modules were recalled for erratic delivery. Choose OEM or OE supplier pumps to hold pressure and avoid knock and $3,000 piston damage. Cooling systems decide how long engines live. Budget radiators change that math fast. Number 8, budget radiators. It looks the same from the front until summer traffic exposes the shortcuts. Budget radiators hide thin cores and fewer fins, so heat rejection drops fast when the fan cycles and the AC loads the system. Poor brazing and weak plastic tanks split under pressure, bleeding coolant and pushing temps into the danger zone. Fin density, tube count, and sloppy end tank crimps tell the story. Integrated ATF and CVT coolers demand exact spec. Failures can cross-contaminate fluids and destroy a transmission. Alloy quality and electrolysis resistance matter. Cooling capacity tests back the gaps. OEM guidance on coolant type and cap pressures isn't optional. Proper radiators stabilize temps and protect head gaskets and transmissions. Suspension looks simple. Universal parts can quietly rewrite your crash physics. Number 9, universal suspension parts. One-size-fits-all bushings don't just squeak. They can change where your body goes in a crash. When geometry and durometer don't match OEM spec, alignment shifts under load, and your car stops behaving like it was tuned to. Under braking, softer control arm bushings allow unintended toe change that steers the car mid-stop. Altered ride height and damping change pitch and roll rates, which the ABS and ESC expect to be consistent. Crash test narratives show non-OEM repairs increase seatbelt webbing pass-through from about 8 inches to roughly 13, throwing off airbag and belt sync. OEM procedures demand exact parts for this reason. Use OEM spec suspension to preserve predictable energy management. Electrical loads are next. Cheap alternators fail quiet, then kill everything at once. Number 10, cheap alternators. The light flickers, then your steering goes heavy at 70 miles per hour. That's a budget alternator announcing itself. Weak diodes and sloppy regulators let voltage spike, then sag, stressing every module on the network. A hot restart turns into a stall when a brownout resets the ECU and fuel pump together. On a scope, clean output looks flat. Cheap units show tall ripple ridges that cook batteries and confuse sensors. Thermal derating hits early, bearings whine, and output collapses. Low voltage can drop ABS and ESC right before a stop. OEM specs call for tight regulation and low ripple. A quality or OEM reman alternator delivers clean power and protects thousands in electronics. Vibration control matters. Bad mounts can wreck more than your comfort. Number 11. Low-quality engine mounts. The cabin buzz is annoying until the shaking starts breaking parts. Low-quality engine mounts use soft rubber and weak hydraulic chambers, so the drivetrain rocks harder on throttle and decel. That motion stretches axles, hammers exhaust flex joints, and throws heat into nearby components. Excess movement also shows up in drivability. Shifts feel harsh as the powertrain twists against slop. Knock sensors and crank variance monitors see noise and can trigger misfire counters. Active mounts need exact vacuum or electronic control to manage NVH. Off-spec units upset that balance and hide real faults. OEM spec mounts restore alignment and sensor harmony, preventing cracked downpipes, fractured brackets, and false diagnostics. Shortcuts in software are worse. No-name tuners can quietly cook an engine. Number 12. No-name ECU tuner/chips. Plus 30 horsepower on paper, minus years of engine life in practice. No-name ECU tuners push timing, boost, and leaner lambda without updating knock strategy, so EGTS spike, pre-ignition starts, and catalysts overheat. Logs tell on them. Learned knock climbing, short-term trims pegged, and overboost events tripping failsafes. OEM calibrations bake in thermal limits and emissions control for fuel quality and weather. Strip that out and you get ringland failures and turbo overspeed that ends in shrapnel. Warranties vanish, and limp mode defeats hide danger until parts fail. SAE literature stresses safety margins for a reason. Use reputable, vehicle-specific calibration, or stay stock. The last silent killer hides in your wheels. Number 13. Bargain wheel bearings. The hum gets louder every week. Then the wheel changes lanes for you. Bargain wheel bearings cut cost with soft steel races, thin seals, and grease that breaks down when heat builds. That's when the play starts. The ABS ring wobbles, and the module reads chaos right as you brake hard. You'll see heat discoloration on the hub flange and leaking cooked grease at the seal lip. Extra clearance throws off wheel speed signals, so ABS and ESC pulse at the wrong time, lengthening stops. Low-quality kits often skip torque-to-yield axle nut specs, so preload drifts.